Alright guys, our topic today is adding and subtracting numbers in scientific notation. Yesterday we talked about multiplying and dividing numbers. The day before we talked about comparing them. Adding and subtracting scientific notation is pretty much the last topic in our scientific notation unit. And I'm not going to lie, it is probably the trickiest. We're going to do lots of practice on this until you feel really comfortable with it. And I think you'll get the hang of it. So tonight for this video, follow along, write the notes, but please do not panic if you're confused at the end, okay? So our heading today is adding and subtracting scientific notation, and our objective is simply I can add and subtract numbers in scientific notation. So let's go ahead and just talk about some of the steps for doing this. Our first step is going to feel a little bit weird. You're actually going to be making fakers. All along with scientific notation, we have been wanting to get rid of those fakers, those numbers that kind of pretend to be scientific notation but aren't actually because the first number isn't between 1 and 10. But we're going to be changing our numbers in our problem until they have the exact same power of 10. And in order to do that, we have to make some of them fakers. And you'll see what I mean in just a minute. After you do that, you're going to add or subtract the decimal numbers from the fakers that you just made. And then you're just simply going to keep the power of 10 as it is. Okay, so if both numbers had 10 to the third, your final answer would have 10 to the third as your power of 10. And then finally at the end, you're going to fix fakers. So in step 1, we're making fakers. And in step 4, we're going to be fixing those fakers. Okay? So let's go ahead and just dive right in and try a problem example. Our first problem, go ahead and do this on the next page in your notebook where we're going to work out some examples. You can put the heading examples. And we have 3.45 times 10 to the third power and 4.65 times 10 to the fourth power. It's kind of like when you're dealing with fractions, and let's say you have 3/4 plus 1/3. You can't just say, oh, it's going to be 4/7. That is not equal, because you can't just add the numerators and add the denominators. You need to find a common denominator to do that fraction problem. So it's kind of similar to what we're doing now with scientific notation. We can't add these because they don't have a common power of 10. So what we have to do is we have to make a faker. Okay? And in this case, probably the easier number to make a faker is going to be this one, 4.65 times 10 to the fourth. You could really do it with either number, and I'll show you how in a minute. But let's start out by making this second scientific notation number into a faker. So I need this exponent 4 to go down 1. I need that to become a 3. So my changed number, my faker, is going to be having a power of 3, and in order to get that to go down 1 to 3, I have to move my decimal point to the right. Okay? So that is now going to be 46.5 times 10 to the third power. Once I do that, I now have two numbers that have the same power of 10. It's a really weird multiplication sign, sorry. So if I look at what my notes say to do, I am going to add or subtract the decimal numbers. Okay, so I have 3.45 plus 46.5. If you remember how to add decimal numbers, you line up that decimal point and add place value zeros where you need them. So 5 plus 0 is 5. 4 plus 5 is 9. Slide that decimal down. 3 and 6 is 9. And I have 4. So it's going to be 49.95. And then our power of 10, if we look back to step 3, we're going to keep the power of 10 as it is. So we're going to keep 10 to the third power. But are we done yet? Is that our final answer? I hope you said no, because our step 4 is to fix the fakers. Even though we just made a faker, in our second step, now we have to fix this faker. So this decimal point has to go back over to the left one spot, which means my exponent is going to go up 1. So I have 4.995 times 10 to the 4th power. And in writing that, I noticed that I made a little mistake. That is not supposed to be a plus sign. That should be a multiplication sign. So our final answer for this one is 4.995 times 10 to the 4th. Now, I said earlier that I could actually go through and make either one of these numbers the faker, and it would be perfectly fine. So I'm going to go and I'm going to show you how to do the same problem, making the first scientific notation number a faker. So I have 3.45 times 10 to the 3rd. And I need to make this a number that has a power of 10, that's 10 to the 4th. So I need my exponent to go up 1. In order for that exponent to go up 1, I have to move this decimal place to the left 1. So it's going to be 0.345 times 10 to the 4th. And then I'm going to be adding that to 4.65 times 10 to the 4th. So when I add these decimal parts, once again, line up that decimal point, 4.65 plus 0.345, add a placeholder 0 where you need it. And when I do this addition, I end up with 4.995 as my decimal part times 10 to the 4th power. And I don't have to fix that because that's not a faker. That is a number between 1 and 10. So now let's go back and see if that gives us the same answer as when we had, changed our second number in scientific notation. So I'm just going to click the back button a few times. Don't forget this number, 4.995 times 10 to the 4th. And if I go back through all of these steps that I just did, look, 4.995 times 10 to the 4th. So you see, you can do either one. You can change either one to be a faker. It's fine as long as you follow the rules. There's multiple ways to get your answer. Let's try another one. This one is subtraction, okay? And it's a little bit more complicated because my exponents, here I have a positive 2, here I have a negative 2. They're a little bit farther apart. I think working with negative numbers is harder than working with positive numbers, so I am going to go ahead and turn this second scientific notation number into a faker because I want to get rid of that negative 2. So I need my power of 10 to actually be 10 to the 2nd power so that it matches this one. So I'm going to have to go up 4 numbers to get from negative 2 all the way up to positive 2. When I go up 4 numbers, I am going to be moving this decimal place to the left 4. So 1, 2, 3, 4. All right, fill in some zeros there. And it is going to be 0.000211. Running out of room, squishing my numbers together. Sorry about that. Times 10 to the 2nd. And I'm going to be subtracting that from 5.11 times 10 to the 2nd. Okay? So they now have the same power of 10. And I can subtract my decimal parts. So I can do 5.11 minus, remember, line up those decimal points, 0.000211. Oh, I have a lot of placeholder zeros here. Man, that's an annoying problem, isn't it? I'm going to have to do quite a bit of borrowing here. I want you to see if you can figure out that borrowing on your own right now. I'm going to count down from 5, pause the video, try and solve that problem, Actually do it. Don't just pretend that you're doing it. I know some of you guys do that. And then you can check it against my answer. So pause the video in 5, 4, 3, 2, 1. All right, you should have gotten 5.109784 as your answer for the decimal part. And then if we follow our steps for the notes, let's look back and see them. Keep the power of 10 as is. So we are going to keep it times 10 to the second. And this is not a faker because 5 is between 1 and 10. So hopefully you guys get a little bit of an understanding of this. We are going to do so much practice on this kind of problem in class tomorrow. So for your reflection, I want to see if you can figure out how to answer this question here. 6.13 times 10 to the 5th power plus 3.24 times 10 to the 4th. Make sure that you follow the steps and at the end get rid of any fakers. Have a great night, and I look forward to seeing your responses on Edmodo. Have a great one, guys. Bye-bye.